Hey there, in this video I'm going to show you how to use energy to calculate the speed of a snowboarder when she's gone halfway down a ramp. So in this case, the snowboarder starts at the top of the ramp, which is 12 meters high, and she initially has 7,800 joules of potential energy. And actually I'm going to do this instead. So she starts off with potential energy, and it says she also has a kinetic energy at that point as well. Now, as she falls, she reaches the midpoint, and she's going to have a smaller potential energy because she's not as high up, which means that she's going to be going faster, so she's going to have a bigger kinetic energy than before. And the question we have is, how fast was she going at this point when she's halfway down the ramp? So here's how we set it up. We know that the energy before, at the very start of the problem, has to equal the total energy after, at the end of the problem. So before we had this potential energy plus kinetic energy, which according to the setup of the problem was 7,800 joules plus 2,080 joules. And that's the total energy at the start of the problem. So this is 9880. Okay. At the end of the problem, when the skateboarder's halfway down the ramp, we know that she's got potential energy, which is equal to mgh, and she also has kinetic energy, which is equal to 1/2 mv squared. So we got to plug in everything that we have. Now we don't know her mass, so I'm going to keep that as a variable for now. But we do know the acceleration due to gravity is 10. And at the point where she's halfway down the ramp, we know that her height above the ground is 6 meters. And we're also trying to figure out what the velocity is at this particular location. Okay, so it seems we have two variables here and don't really know how to solve that. But fortunately for us, we can figure out what the mass is, because we know at the very beginning her potential energy was equal to 7,800, and we know that she had a height at that point of 12 meters. So if we plug in 12 meters and we know that she had 7,800 joules of energy, then we can figure out what her mass is, because you figure that her mass at the start of the problem is the same as it was at the end of the problem. And so what do we get when we take 7,800 divided by 10 times 20, or 10 times 12? We get 65 kilograms is her mass. Okay, so that's good. So I can plug that in up here. 65 kilograms, and also plug that into the kinetic energy. Perfect. Alright, so 9880, we've got 60 times 65, which is 3,900, and then 65 times a half is 32.5. So using this, we can solve for v squared. I'm going to subtract 3,900 from both sides. That gives us 5,980 equals 32.5 v squared. And now I just need to divide that by 32.5. That gives us 184 is equal to v squared. And don't stop yet, because we have to take the square root. When you do, you find that she had a velocity of 13.56 meters per second, and that was her speed, or velocity, halfway down the ramp.